Hi everyone. From this video, I'll be discussing the 2019 center of gravity question because this is quite different when considering about the past papers questions, because we know that in our syllabus mainly we are learning about finding the center of gravity of a symmetrical composite object, but in the syllabus they haven't specially or specifically mentioned that finding the center of gravity of asymmetrical composite objects are not in the syllabus. They haven't mentioned such a thing. As an example, in the year 2009 and then 2014, finding center of gravity of a asymmetrical composite object has been asked through the applied paper, yellow applied paper. So in continuing that, they have also asked finding the center of gravity of this asymmetrical composite object in the 2019 paper also. So in any place in the syllabus, they haven't mentioned that students don't need to learn about finding the center of gravity of a object which is not symmetrical. They haven't mentioned such a thing. So in this, I selected to do this question because in 2019 paper, they have given us a symmetrical object, composite object. So I'll be teaching how to find the center of gravity of a symmetrical object. Okay, so when talking about the question, now in the screen you can see the question. So if you don't have the question, just pause the video and write down the question. The question states, show that the center of the mass, number 1, of a thin uniform semicircular wire of radius A is at a distance 2a over 5 from its center, and Roman number 2, a thin uniform hemispherical shell of radius A at a distance of a over 2 from its center. So I'm not going to do those two things because we know under center of gravity, we have to find the center of gravity of 6 basic objects. They have given a uniform semicircular wire and uniform hemispherical shell, and those two are 2 out of the main 6 the basic 6 objects which we know to find which we should know to find the center of gravity. So just advice, like when we are going to the exam, like we know at the beginning of the center of gravity, any center of gravity question, we have to find the center of gravity of one of these basic objects. So when we go to the exam, like don't just waste your time to think at that moment and think away how can I do this and just find the center of gravity of a basic object, because we know in the paper for a second part question we have only allocated around 28 minutes. Within that 28 minutes I have to complete the entire question. I have to complete this entire question. I have to prove these two, and I have to find the center of gravity of this asymmetrical composite object, and then I have to complete the equilibrium part. So practice well how to find the center of gravity of the 6 basic objects, and when you go to the exam you will just get 1 out of those 6 or maybe 2 like in this question. Then you can just easily prove it and get around 30 marks for this question. For proving the center of gravity, finding the center of gravity of the uniform semicircular wire, they have given 25 marks, and for the uniform hemispherical shell they have given 30 marks. So even though you won't be able to complete the entire question, just by finding the center of gravity of the one of the 2 of these basic objects, you can get 55 marks. Okay, so I'm not going to do that because in the theory note you can easily find, if you just refer to the theory note of your class under center of gravity, you can just find how to find the center of gravity of 6 basic objects. Okay, so I'll just move into the question where we have to find this asymmetrical center of gravity of this asymmetrical composite object. I'll just give a quick brief about center of gravity. Finding center of gravity of composite objects. I know when the object is like this, if this is a cone, any cone, solid or hollow cone, and this is any hemisphere, like it can be hollow, it can be a solid one. I know when considering the center of gravity of the cone, the center of gravity of the cone lies on the x-axis somewhere like here. The center of gravity of the sphere also lies somewhere on the x-axis. So when those two center of gravities are on the x-axis, which means the center of gravity of the composite objects, which means the resultant of W1 and W2, obviously it also lies on the x-axis, because this is on the x-axis, this is on the x-axis, and this is on the x-axis, which means they make a straight line. But when we are talking about this is because we know the object is symmetrical about the x-axis. This is symmetrical about the x-axis. But when we are talking about a symmetrical object like this, something like this, I know the center of gravity lies somewhere here, but this one, the center of gravity is somewhere like here. So it is clear this object is not symmetrical about the x-axis. This center of gravity is here, this center of gravity is here, which means the center of gravity of the resultant, the center of gravity of the composite object lies somewhere like here, W1 plus W2. So in this previous one, we only needed to find the distance to the center of gravity from the y-axis, because this one, we only needed to find this one because we already know that the center of gravity lies on the x-axis. But in this one, the specialty is we have to find the distance to the center of gravity from the y-axis and even from the x-axis. We have to find both those distances, because we know the center of gravity means a point. We have to find both the x coordinate and the y coordinate of the center of gravity. We have to find the distance from the y-axis and the distance from the x-axis. So I think it is clear. So let's move to our question. Now, when considering about our question, you may have a problem. How can I draw this in the coordinate plane? How can I draw this? How should I draw the diagram? From where should I take moments? Like a student who is doing this question may face such problems. For example, I'll take this as the y-axis and I'll take this as the x-axis. Most of the students tend to draw a diagram like this. I'm taking my, just read the question well, okay, because I'm not going to read the question. This is a hell lengthy, so I'm not going to read the question. So you just read it well, read it twice or thrice and then watch the video, okay. If you don't have the question, just pause the video and read the question twice or thrice and then watch the video. Then this is spoon and they have given a straight rod, and then here comes the handle. So I know, like, they have given this is A and they have given this is O. So if this is O, don't take this as O also, because they have given this as O. And this is B, C somewhere here, D somewhere there. Now they are asking, like, now look, if somebody draws like this, I'm taking the center of gravity somewhere like here, and I'm finding this distance x bar, and I'm finding this distance y bar. I'm talking about, like, most of the students are drawing this diagram in this way, okay? Because this is the way they are used. No, this is like totally correct. Anyone can't say that drawing the diagram in this way is wrong, okay? This is correct. The difference is, like, they have specifically asked us, show that the center of mass means the center of gravity, the same point. When we are considering about weight, it is the center of gravity. When we are considering about mass, it is the center of mass. Show that the center of mass of the spoon lies at a distance, like they have given a statement, below OA. They are asking to find the center of gravity from OA. Means they are asking that it is below OA. So we have to find the distance to the center of gravity from OA, and they are asking the distance from OD. From the distance from a straight line going through OD. So we have to find this from this distance. So this is correct, distance from OD, and we have to find this distance, not this one. We have to find the distance from AO. So if somebody draws a diagram like this, and then that particular guy or girl has find the center of gravity as x bar, I know to find the final answer. They have given the radius 2a, so I have to reduce 2a from x bar, because they are asking the distance from AO. So I just found the distance from the y-axis, which is x bar. So I had to reduce this radius 2a from x bar to get the answer, get the distance to the center of gravity from AO. So it is okay, totally okay, but I know when we need to save time, we need to conserve time when we are doing the paper. So in this one, we have to find x bar and then we have to reduce it. So another step, which means, like, we will just spend in another 30 to 40 seconds and it is useless. So what I do, the system I am recommending is, if they are asking to find the distance from OD and AO, take the x-axis and y-axis as AO and OD. If they are asking to find the center of gravity from AO and OD, Then take the x-axis and the y-axis as AO. So take the y-axis as AO. So this is my A, this is my O. And it continues like this. We get B, C and D. B, C and D. So this is B, this is C and this is D. So now it is clear. If we mark the center of gravity somewhere like here, we have taken the distance from AO is x bar. We have taken the distance from OD as y bar. So we directly get the answer. So the method I am suggesting to draw the diagram to take the moments in order to find the center of gravity, the best way, the easiest way is this, because then we can directly find the distance from AO and the distance from OD. It is clear. We know that when we are finding the center of gravity of a composite object, even though it is symmetrical or asymmetrical, we have to separately find the masses of each part. So I'm just using a small chart. I'm doing the object and I'm taking the mass. First I'm considering about the hollow hemisphere. They have given this as A and this point as O. And we know the radius of this one is 2A. They have given it. Read the question properly. They have given the radius is 2A. I know the surface area of a globe. We learned this around somewhere in grade 11 or 10. The surface area of a sphere is 4 pi r squared, which means the surface area of this hemisphere is given as 4, half of this 2 pi r squared. These are the things we should know, basic maths. Without these stuff we can't complete this question or any other question. You have to know that the area of this hemisphere is given by 2 pi r squared. So I'm taking the area is 2 pi r squared, and here we know r is 2a means 2a squared into, they have given the mass of a mass per unit area. The mass per unit area of the hemisphere is sigma. We know to find the mass we have to multiply the total area by the mass per unit area, then we get the total mass, and it is, we know 2a squared means 4a squared and 4 into 2 means 8. We have 8 phi a squared sigma. This is the mass of the hemisphere. Then I'm considering the rod AB. If I mark this as W1, I'm marking this as W1. I know the distance from the center of gravity from O. This is 2a, means the radius is 2a. So I just proved that the center of gravity is half of the radius from the center. So which means this distance is a. We know that because the radius is 2a and the center of gravity lies half of the radius from the center, which means this is a. And in this is a uniform rod. I know I'm taking the weight as W2. And they have given that the length of this rod is 2 phi a. This is a uniform one, which means the center of gravity is at the midpoint. We know this is a rod, which means a length. So they have given the mass per unit length is a sigma over 2. I know the total length of this. The total length of this is 2 phi a. Total length of this is 2 phi a. To get the mass, I have to multiply 2 phi a by a sigma over 2. I know when we are proving the first part of the center of gravity one, to find the center of gravity of this uniform semicircular wire, we are just used to take like mass per unit length is a k, like we use a symbol. We know we are using mainly in center of gravity the mass per volume as rho, mass per unit volume as rho, mass per unit area as sigma, and then mass per unit length as k. Those are not standard symbols, but we are used to use such things. So in this one, like they have given the mass per unit length as a sigma over 2, because then it is clear 2 and 2 goes, we get an answer, similar answer. This is phi a squared sigma, this is phi a squared sigma. Those are similar answers, 8 phi a squared and phi a squared sigma. So when it is easy when we add in these stuff, when we are subtracting these stuff, it is easy and they easily cut off. That is the reason they have given the mass per unit length as A sigma over 2. And then I'm taking the final one, the semicircular arc, and if I take the weight of it as W2, W3, I just found that the center of gravity is at a distance of 2a. They have given the radius of this is a, so the distance is from the first proof 2a over 5, because in the part 1 we find the center of mass of a thin uniform semicircular wire of a radius a lies at a distance, so is at a distance 2a over 5. So I know this is, to get the mass I have to multiply the length from the mass per unit length. The length gives by, this is a semicircle, the perimeter of the length of a circle is 2 pi r, so this is a semicircle means phi r, and r here is a, radius is a, into mass per unit length a sigma over 2, so we get the answer. The mass is phi a squared sigma over 2, phi a squared sigma over 2. We have 3 masses, and then I can consider in this, I can write the total mass. When considering these 3, I can write the total mass. 8 plus 1 is 9, 9 plus half. 9 plus half means, when we take 9 as the common denominator, we have 18, 18 plus 1 is 19. So the total mass is 19 phi a squared sigma over 2. This is the total mass. This is easy. Let's do it. And then I'm considering take the moments, and as we discussed, I'm going to draw the x-axis and y-axis as AO and OB. So I have a shape like this. I'll take this somewhere here. Total mass 19. You can just easily find this. Let's draw the weights. I took this as W1, I took this as W2, and this as W3. I know the length from this one, it is A, this length is phi A, and the length from here is 2a over 5. This length is 2a over 5. I drew it in here, this is 2a over 5, and we even proved that in the first part of this. And I'm taking the center of gravity a point somewhere like here, so this is the total weight, and I'm taking this distance as x bar and this distance as y bar. So I'm going to take moments around O, I'm considering the clockwise moments. So I know what is the moment equation. Moment equation is the moments of each force to a certain direction from one point. The moments about one point to a certain direction, or the resultant or the addition. We are saying the addition or the resultant of all the moments or all the moments around one point about one point to a certain direction is equal to the moment of the resultant force. So these are three forces, W1, W2 and W3 are the three forces. W is the resultant, which means the moments about O, the moments of W1, W2 and W3 around O is equal to the moment around O of W, is equal to the moment of W around O. So I'm considering the clockwise direction, but I have W2 to the anti-clockwise direction, which means it is minus W1 over the perpendicular one is into A. Then W2 gives a positive clockwise moment, W2 into phi A, plus W3 gives a clockwise moment which is positive into the distance. Look, the distance, this is phi A. This is phi A means 2 phi A plus 2 phi A plus this part. This part is 2A over 5. This part is 2A over 5 equals, the moment equation says the resultant of the moments around a point to a certain direction is equal to the moment of the resultant about that point to that particular direction, So all I took as clockwise moment. So equal to W gives a clockwise moment, W into the distance is x bar. The distance is x bar. So let's write the value. I took W1 as 8 phi a rho sigma into G, because this is the mass and I'm considering the weight, into A, plus W2. W2 is phi a squared sigma G into phi a, plus W3 is phi a squared sigma G over 2 phi a plus 2 over phi. And the total weight is 19 phi a squared G over 2 into x bar. I get this equation. It is clear. So I told you why they have given a mass per unit length like this one using a sigma over 2, because then we get a similar shape. So we can cut off this one. Phi a squared sigma G, phi a squared sigma G, phi a squared sigma G, and phi a squared sigma G. I didn't write the sigma G. So which means I get minus a plus phi a plus half into 2 phi a plus 2a over phi is equal to 19 over 2 into x bar, 19 over 2 x bar. So if you want to copy this down, you can pause the video and copy this down, because I'm erasing this part. You can pause it now. I'm erasing this part and I'm moving for my simplifications. When I take this one, I get minus a plus phi a, and multiply by half, I get plus phi a. Multiply by half these two cutoffs, and I get a over phi equals 19 over 2 x bar, 19 over 2 x bar. So I get minus a plus 2 phi a plus a over phi equals 19 over 2 x bar. And I'm taking minus a over phi out, and I get this one is, there was the minus, there was no phi, so this is 8, right? Sorry, I just missed it. Minus 8. So this is plus 8. I took minus out, which means this is minus. And minus I took over phi, so this gives us 2 phi squared. This is minus 1 equals 19 over 2 x bar. 19 over 2 x bar. So I get the answer as x bar is equal to, x bar equals multiply by 2 minus 2a, take by 19 over 19 phi, 8 minus 2 phi squared minus 1. I have got a similar answer that they are asking, but the thing is I got a minus. It is clear that they ask, show that the center of the mass of the spoon lies at a distance of this below OA. They are asking that the distance is, this is A, is below OA, which means if I turn the spoon like this, the distance, the center of gravity should lie on a point somewhere inside here, but I took as outside. So that's why I'm getting the negative answer. What I mentioned earlier, it is okay even though we mark the center of gravity here or here. But if we mark it here, we get the correct positive answer. But if we mark it here, we get a negative answer, because according to the question, the center of gravity is supposed to lie inside. Or below OA, but I have just drawn it as it is outside or above OA. So I get a negative answer. So I can write the final answer. Therefore, I can write the final answer. Therefore, G is 2a over 19, 8 minus 2 phi squared below from, because this minus answer is above OA, which means a positive below OA. We get the first answer. So it is clear. So I hope this is clear. Even when we have to find in the center of gravity of a symmetrical object, this is the similar method, because we have to find the distance from the y-axis. So this is quite similar with you. But now I'm moving to finding the center of gravity from the x-axis, which means we have to turn this diagram. The diagram was like this, and I'm drawing the diagram in a vertical direction. First I drew OD and AB as horizontal lines, and now I'm drawing it as a vertical line. So I can get something like this. This is my spoon, and it goes like this. So we have O here, we have A here, D, C, and B. I'll mark the weights. This is W1. This weight is somewhere in the midpoint of the straight rod. It is W2, and this is center in this line. This is W3. I know this distance is A. I know this distance as 2A. When I consider the center of gravity, I took it as G, and first one this is W. In the previous one, I just mentioned this as X bar, and I mentioned this as Y bar. It was really I mentioned. I put the distance from the, because now I turn the axis. I turn the axis, which means the x-axis goes to here and the y-axis comes here, because I'm turning the axes. I'm turning the axes. Now my y-axis is here, my x-axis is here. And even in the previous one, I have mentioned, and like the distance to the center of gravity from OD or from the x-axis is y bar. So now this is more easy. This is more easy than the previous one. I'm considering moments around O, and it is clear. There's no moment from W1 because W1 goes through O, which means there's no moment from W1. Then we are going to W2. W2 into W2, the perpendicular distance is 2A plus W3 into the perpendicular distance is A is equal to the resultant W into the perpendicular distance is Y bar. This is Y bar. This is C. We substitute, we got W2 as A phi A squared sigma G into 2A plus I got W3 as phi A squared sigma G over 2 into A equals, the total weight was 19 phi A squared sigma G over 2 into Y bar, which means as the previous one, phi A squared sigma G, phi A squared sigma G, phi A squared sigma G cutoffs, and I get 2A plus A over 2 is equal 19 Y bar over 2, 19 Y bar over 2. So I'm taking 2 as the common denominator. I get 4A plus A over 2 is equal to 19 over 2 Y bar, 2 cutoffs, and I get the answer they are asking. Show that the distance to the center of gravity from the OD is phi A over 90. So it is clear the center of gravity lies at a distance of phi over 90 from the OD axis, So I hope this is clear. So after this we have equilibrium part, and I'll be doing it. I'll be completing the whole question. But what I want to mention you, what I want to specifically tell, that even if you stop this question from this point, already you have got 120 marks out of 150, because for the proof of the basic two objects, they have given us to prove in the semicircular wire you got 25, to the hemispherical shell you got 30, which means 55, and for this proof for getting X bar and getting Y bar, they have given us 65 marks. So altogether, even though I won't be able to complete the equilibrium part, I have got 120 out of 150. So what my view is, if they are asking to prove to find the distance to the center of gravity of basic objects, like of 2, normally they are asking 1, but in this one they have asked 2 basic objects. If they are asking 2, that means it is an advantage for you, because you have to practice well to find the basic object, the center of gravities of the basic objects, of the 6 basic objects. So if they are asking 2, you can easily get 55 marks. But if they are asking only 1, you can get around 30 or 40. So it is an advantage to the student if they are asking 2. So in the center of gravity 1, without the equilibrium part, you already have taken 120. You have already have taken 120. So I'll be doing the equilibrium part, and they are asking something related to friction. They have kept this spoon vertically, like OD and OB are vertical, and they are asking to show that they are asking the spoon can be kept in equilibrium. They're asking that it can be kept in equilibrium. So I'm just drawing the figure. And I'm telling you how to think to get the answer. The way we should think to get the answer. Now, first let's mark the forces. A, O, D, C. In the previous one, I just mark all the masses or weights of each object. Now I know that the center of gravity is lying somewhere here. Like this distance, I know it's x bar. This distance, I know it's y bar. I know that. So I'm taking the weight as W. If you want, you can take it as like 19 phi a squared sigma GO2, but that is not essential because just take the weight as W. And mark the other forces. I know this flow is rough, which means there's a friction force. The object tends to turn to this direction, which means this point, if I take this point as E, the point E tends to move to this direction, to the left hand side, which means the friction is to the opposite side. The friction is to the opposite side. And I'm taking the perpendicular reaction as R, this weight. And this is kept at equilibrium. This is kept in equilibrium by using a horizontal P force like this. So this is the basic system. So how can I approach? What is the approach I should make in order to get this correct, in order to complete this question? They're asking us, show that the spoon can be kept in equilibrium. So we know if F over R ratio, F is to R ratio, F over R ratio is less or equal to mu, which means F hasn't reached the limit in frictional force. So I can tell that this can be kept. Oh, this is at equilibrium. Because I know if F has reached to the limit in frictional force, at the very next moment, the equilibrium in this system, the equilibrium loses. The equilibrium loses if the frictional force has reached the limit in frictional force. In the very next moment, the equilibrium of the system will be lost. So what I need to find, I have to find F in terms of W, and I need to find R in terms of W, and I have to find F over R ratio. I have to find the F over R ratio, and I have to show that it is less than mu. In this one, they have given us mu, the friction coefficient. The frictional coefficient as 107. So I have to show that F over R in this one is less than 107. Finding the center of gravity, since this is asymmetrical, the object is asymmetrical, it was hard and it was quite lengthy. I know that, I accept that finding the center of gravity was quite hard and quite unusual with the students because it was quite lengthy. But the equilibrium part is so easy. The equilibrium part is easy. I'm taking moments around E. I'm taking moments around E to the clockwise direction. I know F doesn't come and R doesn't come because those two forces go through E. So I'm getting W into this y bar, the perpendicular distance y bar, E minus, and P, the perpendicular distance, this is 2a, the radius of the hemisphere is 2a, which means P into 2a is equal to 0 because this is at equilibrium, So W into y bar we got as 5a over 19 is equal to TA over P, which means we get P as. Now I have an objective. My intention is to find, this is 5W over 2 goes down and it becomes 38. My intention is to find F and R in terms of W and get the F over R ratio, So I'm going to find F, I got P, and I'm considering the horizontal forces, which means we have F to this side and minus P to this side is equal 0 because the system is at equilibrium. F equals P, and I got F as 5W over 38. And when we consider in the vertical forces, we get R minus W is equal to 0, which means R equals W. I told my intention was to find F and R. I have found it, and to go to the F over R ratio, and to go to the F over R ratio, I'm considering 1 over 2. I get F over R is equal to 5W over 38 over W. 5w over 38 over w, and w cancel off, and I get f over r is equal to 5 over 38, which means it is equal to somewhere like 0.13. But I know they have given the coefficient of friction is 1 over 7, which means it is somewhere like 0.14. So I know this 0.13 is less than 0.14, which means f over r is less than 1 over 7. So we have f over r is less than mu. So I can assume that the friction hasn't reached its limiting frictional force level. The friction hasn't reached its maximum level. So by writing this inequality, f over r is less than mu, I can write therefore system is at equilibrium. System is at equilibrium. For this equilibrium part, I get 30 marks. So altogether, I can get 150 marks. I decided to do the center of gravity question because one reason is center of gravity is a single question coming in the applied. One and only the simple harmonic motion one and the center of gravity are the two questions coming from single lessons. I know every other question is coming as combined questions. For example, planar forces comes with vectors, VT graphs come with relative velocity, and statistics come with probability. Jointed rods comes with framework. I know that this one comes alone as a single question, and we can easily get 150 if we just follow the steps correctly, if we write the things correctly, and if our simplification is good, we can easily take 150. I selected this one because I needed to teach you to find in the center of gravity of a symmetrical composite object, which means you have to find both x bar and y bar in an easy way. And through this video, I mentioned some special techniques when they ask in the distances from AO and OD, take those lines as the axes as my x-axis and my y-axis. Keep them in mind, and because this finding the center of gravity of a asymmetrical composite object were first asked in 2009, then 2014, and then 2019. But I can't predict that it is coming again in 2024. We can say something like that. It can come in 2020. It may come in 2021. We can predict it. So it is good if we can just practice this. And the special thing I didn't do the first part. Finding the center of gravities of these two objects, which are two of the 6 basic objects. Practice those 6 well at home. Then when you go to the exam, already you have gained like 50 to 40 marks, to 40 to 50 marks if you can prove the center of gravity of a basic object. So this is the way how the 2019 center of gravity question is done.